Good morning, everyone, and welcome to our first webinar in the Wimmera Productive Soils Series, supported by the Wimmera Catchment Management Authority through funding from the Australian Government's National Landcare program. My name is Prue Cook. I'm the Director of Nine Creeks Consulting, and I'll be your webinar host across the series. This webinar series explores farm practices and innovations that Wimmera farmers can use to increase soil organic matter and improve profitability. The webinars will examine existing and emerging approaches, focusing on local relevance and delivering current research, essential considerations and guidance on implementation. Let's get straight into today's topic of intercropping by introducing today's presenter, Ash Wallace. Ash is a research agronomist who has worked for AgVic at Horsham since 2007. Ash has worked across a range of areas relating to crop agronomy, soils, climate and nutrition, with a particular focus on nitrogen. He's recently been working on a project led by Gary O'Leary in conjunction with colleagues across the state, investigating intercropping and its potential to increase farm profits. Before I hand over to Ash, we will have time for questions at the end of Ash's presentation, but you can type your questions in at any time using the chat function that you should see on the right-hand side of your screen. You'll also be sent a recording of this webinar after it finishes, so don't worry if you do need to leave early. Over to you, Ash.
Thanks, Prue, and thanks to those who are coming along to today's webinar. So as Prue mentioned, today I'll be giving you guys a quick rundown through some of the results that we've been generating from our work looking at intercropping in the Wimmera, and some of the challenges that we see going forward for implementing this into farming systems locally. So before I start, just want to say thank you to the co-authors on my presentation, as well as our broader team of people right across the state who've been contributing to this project. Okay, so to start with, what do we actually mean when we start talking about intercropping? There's a range of different ways that we can go about intercropping, but essentially it is a bit of a multitasking approach to growing crops. So trying to grow multiple crops at once in the same paddock, if you like. The idea of this isn't necessarily a new thing. It's been quite widely used for very long periods of time, and commonly used overseas, particularly in some of the less mechanised type agricultural systems around the world. But the reason that we're testing it here in the Wimmera at least, and more broadly across Victoria, is the idea that it can potentially produce either high yields, or alternatively we can have benefits from similar yields but with less inputs, and it can also result in environmental benefits. And it achieves this through a range of different ways. There's two main ways that we can look at the benefits of intercropping. One is through what they call replacement. And in this case, when we're growing these two or more crops together, we get one of those species actually dominates the other species. And so what we see is that dominant species produces its regular amount of yield, if you like, and then the other species are growing there on the side, almost like a bit of a bonus at the end. They don't necessarily produce a great deal, but they contribute to the overall productivity of the system. But the other more interesting situation with intercropping can arise where we have two species that are actually quite complementary. And so in this instance, we can see one species benefiting the other. The example we might see there is, for example, when you grow canola with field peas, and the canola can provide a trellising structure for the field peas to actually grow taller and actually better utilise the available sunlight that is available to the crop. So in some cases, we can actually see the two working together in a complementary sort of way, rather than necessarily one or the other outcompeting. In practical terms, there's a few different ways, though, that we can actually implement an intercropping system. So, for example, we might have a situation where if we had the water supply, we could sow a wheat crop in, say, April, May, that would then be harvested in November. But prior to the harvest of that wheat crop, we could go in with some sort of a summer type crop like soybean, actually sowing that prior to the harvest of the wheat in between the rows of wheat. And effectively, for a period of time, the wheat and soybean are existing as an intercrop. Now, the soybean doesn't get harvested, of course, until much later on towards the end of summer. But nonetheless, the two have been there coexisting in the same space at the same time. Another alternative intercrop system might be to sow two winter crops together, perhaps something like wheat and vetch. But what we actually do is we terminate one of those two species prior to maturity of the crop. So, for example, if we were to sow wheat and vetch together, and then later on in the season, before the vetch actually starts to set seed, going in and terminating that vetch out of the wheat. And then the final option, and this is where our particular work and the data that I'll be presenting today focuses on, is situations where we actually grow two crops together at the same time, and both of those crops are actually going all the way through from sowing to harvest, and then trying to actually separate those two grain products into their individual constituents. So what does it actually look like in practice? I've just got a few photos here from our Horsham site in 2020, where we put in a range of different combinations of species. So the plot that we've got here in this photo is actually a combination of faba bean and wheat, and this has been sown in what we call a skip row configuration. So if you look across from left to right, you'll see that we sow them as a 6-row plot. We have a row of faba beans, 2 rows of wheat, 2 rows of faba beans, and then wheat on the outside. But essentially what we mean when we're talking about a skip row configuration is sowing 2 rows of one species, 2 rows of the next, 2 rows of the next, etc. And so what it does is, in terms of the space, it gives each crop its own area in which to grow and establish and throughout the season. Conversely, this is another example where instead of establishing it as a skip row configuration, we've actually sown both species into the same drill row. So in this case, this is actually lentil that has been sown with wheat. And what this really shows us here is just how competitive wheat can be when it's sown in combination or in mixture with lentils. If you look very closely, you'll actually see some of the lentil plants really struggling to try and get up through that wheat canopy and trying to find the sunlight. And so this is where we start to look at, are these two species complementary, or is one species dominating the other? Another alternative here, we have a combination of barley grown with canola, and we can see in this instance that the two species are somewhat more compatible. So in this case, the canola has been able to actually establish and get up and going and compete much more effectively with the barley than the lentils necessarily were able to compete with the wheat in that last photo. Okay, so what have we actually been doing during this project? Well, basically we've been looking at a range of different crop mixtures to try and see what works, what types of crop works with what other types of crops, and which ones will actually dominate other crops. So we've been testing combinations of barley canola, field pea canola, faba bean canola, lentil canola, faba bean wheat, and lentil and wheat. And we've been doing that across a wide range of areas in the northeast, the southwest, and also in the Wimmera and southern Mallee. Now, when we combine our different mixtures, the first choice we have to make is what sort of plant densities are we going to be targeting. And so when we sow our plots, we actually put out a range of different densities according to the default density for that particular species. So, for example, we'll sow a plot that might be a monoculture or 100% wheat with no lentil. We might then sow another plot that has lentil at 25% of its usual target density and the wheat at 75% of its target density. Then we would sow a 50-50 where each of the species is cut down by half in terms of its plant densities. And then we might have another combination where we have 75% or lentil at 75% and wheat at 25% of its usual density, etc. So we get all these different combinations of these mixtures at different densities. And then, as I mentioned before, we're also looking at skip row configurations versus a mixed configuration where both species are actually sown in the same drill row. So we get a whole range of different treatments there in terms of the different mixtures and the plant densities across them. Generally speaking, what we're trying to do across all of our treatments is to use herbicide tolerant species, cultivars. Particularly, we've used a lot of IMI tolerant varieties, and where we can, for example, our canola is actually an IMI triazine tolerant variety, just so that we can actually simplify our herbicide management across these sites as much as possible. So in terms of the actual results that we're seeing, before we get into the data, the first thing to think about with intercropping, of course, is how do you actually measure the success or the productivity of an intercropped situation compared to a monoculture. So obviously, when we're growing wheat by itself, or lentil or any other species, we can look at the grain yield of one plot versus another, and we're comparing apples and apples. But once we start growing multiple crops together and at different densities, that starts to become a much more difficult thing. Now, ultimately, I suppose, and we'll come to this later, the measure of success would be the long-term sustainability of profit and how profitable the different rotation or intercropped options are. But in terms of trying to measure the productivity aspects of intercropping, the most common measure that's used is what they call a land equivalent ratio. And this is a bit of a tricky sort of concept to get your head around, or at least I certainly found it to be quite tricky when I first started looking at this data. What the land equivalent ratio tells us is the relative area that would be required to grow a given amount of whatever crop or two crops you're growing in a monoculture or situation versus an intercrop situation. So, for example, if we look at a combination of field pea and canola in a 25%, 75% mix, in this instance, at Horsham in 2020, we saw an average land equivalent ratio of 1.2, roughly speaking. So what that means is that effectively to grow the same quantity of field peas and the same quantity of canola as a monoculture would require 1.2 times the land area that we would otherwise need to have grown them in an intercrop. So effectively, if we have a land equivalent ratio or an LER above 1, that means that intercropping is advantageous from a productivity perspective. And what we saw at Horsham in 2020, if we look across the bars here, we have a red dotted line there to show the LER value of 1. We can see that we had reasonably strong positive land equivalent ratio for the field pea canola mixture. But generally speaking, across most of the other mixtures, whether it's barley and canola, wheat and faba bean, wheat and lentil, we didn't necessarily see really strong changes in the land equivalent ratio or a really strong benefit, if you like, from intercropping. Now, excuse me again. This needs to be set against the backdrop, of course, of the individual year. So 2020 obviously was a pretty high yielding year for us in this instance. So when we look at our actual monocultures of barley, they averaged 6.9 tonnes to the hectare. Our canola was over 4 tonne. Fabers were over 7. Even our lentils were at 5, and our wheat was almost at 8 tonnes to the hectare. So a really strong, high-yielding sort of year for those monoculture crops. And I think that's an important one to consider, because how well these crops perform by themselves really also dictates any potential benefit from intercropping. Now, another site from 2020, this is from up at Netherby, so just not too far south of the Big Desert, actually. It's quite a different soil type to our site at Horsham, much sandier soil and a bit lower rainfall, despite having a reasonably decent sort of finish to the season. And the first thing you see is that the yield potential in this instance was a bit lower. So our barley and wheat were around a 4 tonne to the hectare mark. Lentils were down to 1 tonne, and canola 1.8, etc. So a bit lower yielding sort of site. And what we saw in this instance, if we look across the different combinations of mixtures, whether it's barley, canola at a 25-75 or a 75-25 mix, generally not a great deal different from from 1. So the intercropping benefit across most of these was limited, if not actually a slight reduction in productivity due to intercropping. So in this instance, in this site, the suggestion would certainly be that the greater benefit would come from just going with a conventional monoculture approach. Conversely, we've just got some results here from Wallace in 2021. And in this case, we started to see a situation where, again, not a super high yielding year. So our wheat was around the 2.5 tonnes to the hectare mark. Faba beans were probably one of our better performers there at 3.5, canola 1.2 tonnes to the hectare. But in this case, what we saw was relatively positive and strongly positive benefit from intercropping, particularly for combinations of faba bean and wheat, and to a lesser extent faba bean canola, and even in some cases lentil and canola. So in these instances, land equivalent ratios of 1.2 to sometimes approaching 1.5. So in some cases, it would seem that there is potential there for some significant benefit in terms of the productivity of intercrop compared with the monoculture. Now, broadly speaking, if I compare these results to those that we've been getting from other sites across the state, what we've often found is that in our Wimmera Mallee sites, where our yield potentials are a bit lower than in the southwest and northeast, the benefit from intercropping has not been as consistent. Whereas, in those other environments where they are getting a bit more rainfall, higher yield potentials and more consistently high yield potentials, the potential benefits of intercropping have been a little bit more consistent for those guys in those environments. Now, I suppose that's some of the potential opportunities, but intercropping also brings with it some challenges and some practical issues. And one of them, if we're looking at intercropping from this perspective of growing 2 crops at once and effectively trying to bring them both through to a grain yield, is how are we actually going to separate the 2 products at the end post-harvest? And to this end, our economists have been doing a fair bit of homework and working with industry to actually try and understand what it might actually cost to separate some of these different combinations of species. And what we've got here is a plot of the grain separation and cleaning cost in dollars per hectare as a function of the total variable cost per hectare. And what we can see is that for relatively easy, if you like, easy to separate combinations, things like faba beans and canola, or field peas and canola, where we have large seed and small seed, you would assume that the two could be cleaned based on a screening type approach. The cleaning costs for that combination are a fair bit lower, and certainly lower as a proportion of the overall production. But on the other hand, if we start looking at combinations like lentil and wheat, where we have two seeds very similar size, very difficult to potentially separate, and a much higher cost to actually undertake that separation, and that can really affect the overall cost of production and the profitability of this approach. So I think the message here is not so much that it's impossible, but if we are going to implement these intercrop systems and trying to grow two crops at once, we're going to need to find some practical solutions to bring these costs of cleaning down, and or combined with higher overall improvements in productivity. Obviously, if we've got really significant improvements in productivity, our ability to absorb some of that cost of cleaning can be a bit better. So, in addition to that, there's other practicalities, as I've mentioned before, around weed management. For our situations, we've mainly been working with various tolerances within the cultivars to be able to manage our weeds, but there's also other potential headaches around pests as well. Timing of harvest, we potentially could have situations where we have one species is waiting to be harvested while the other is still maturing. And we also have other complications around nutrition. If we start trying to grow something like canola with a legume, what implications does that have for our end management and things like that, as we start knocking back the density of one species and bringing in a legume, for example. So there's a lot of potential practical considerations that need to be accounted for in all of this. So as I mentioned before, long term at least, profitability and sustainable profitability is the end game. And so as part of this project, we've had a significant component looking at the actual economics of intercropping. And what I've presented here is just a analysis from Horsham. It's just a single year, Horsham in 2020, where we looked at the land equivalent ratio, or LER, and how that related to the net gross margin for that particular mixture. And what we can see is that where we had stronger positive land equivalent ratios, particularly for that field pea canola combination, we generally had positive net gross margins for growing them in a mixture as opposed to monocultures. Now, this is based on an initial estimate of the of costs. However, as the project's gone on, we have actually refined this significantly, as I said before, particularly around our understanding of the potential cleaning costs. And so if we revise those costs to a more of a worst case scenario, if you like, using those higher cleaning costs, what we can see here for Horsham 2020 is that while yes, we still have some positive land equivalent ratios, some positive potential improvements in productivity, the profitability in terms of the net gross margin starts to become a bit more tenuous due to those increased cleaning costs. And then if we apply that same approach to Netherby in 2020, where we actually had certainly less of an effect in terms of the land equivalent ratio and not really that productivity benefit from intercropping, you can start to see in that case that basically the economics just doesn't stack up. So, but ultimately, though, this analysis is not the end game for our economists. So, a big focus on this actual project has been taking the findings from our field experiments and actually inputting them into crop models that are able to look at the response of a crop to intercropping right across the entire state, and doing that across multiple years. And so what the aim of this is to actually then feed that into our economical analysis and actually say, across the entire state of Victoria, where does intercropping work and when does intercropping work? So the ultimate aim here is to be able to say at a particular point across the state, intercropping versus monoculture, and here's the distribution of profitability across time, accounting for different seasons, accounting for changes in prices and things like that as well. So these gross margins are nice as an initial look for sure, but ultimately we are aiming to get towards something that's much more nuanced and really accounts for that risk across time and across space. So I suppose, what does this all mean? Locally, I guess we probably suggest that there may be some opportunities for intercropping, but I think the trick will be identifying when and where. Where is it that these species can be complementary, and where is it that one is just going to dominate the other, and potentially we may not get that intercropping benefit. Some of the challenges, they seem to be mainly associated with harvest and marketability, as I talked about before. That cost of seed cleaning in particular could be a really significant one in terms of the profit. But if we can come up with some practical solutions that manage that cost, then we could really change the game there. Initially, when I was asked about this particular presentation, there was a question mark around soil carbon. We haven't really looked at soil carbon as a part of this particular project, and that's partly due to the fact that, I suppose, to really measure changes in soil carbon is a long-term, slow kind of process. But nonetheless, I think we can probably infer some likely impacts from this work. And essentially, the way that I'd summarise, effects on soil carbon would be that if we're implementing a production system, whether it's intercropped or whether it's monoculture or what have you, if we can increase the amount of carbon that we're putting into the system to start with, so if we're increasing the overall primary productivity of that system, then we can potentially see some improvements in soil carbon. Now, that, of course, can be offset. So if we are implementing a system that reduces the losses of carbon in terms of the way we manage that soil, we can also improve that situation. But the other thing, of course, when we're talking about soil carbon, we need to consider is the amount of nutrients that are required to actually sequester that carbon away, because carbon isn't necessarily stored in soils by itself. It also requires a significant amount of other nutrients in order to stabilise and store that carbon away. So there's a lot of sort of checks and balances there in terms of the potential soil carbon impact. But generally speaking, if we can improve the initial productivity, if we can match that with nutrients and avoid practices that might actually lose that carbon, then we might be able to see some positive signs there. I've already gone well over time, so I'll leave it there, other than just to thank all of my colleagues and, of course, Agriculture Victoria and GRDC for their support of this particular project.
Wonderful. Thank you, Ash. Some really practical farmer-focused information in there. We've got a couple of questions that we'll whip through. One of them you've just covered with your last point around the long-term benefits to soil health. The next question was, were there any nutritional benefits? So, for example, less nitrogen inputs required.
Yeah, we haven't looked at that specifically. The thing with intercropping, I suppose, as you can see, we've already got a wide range of different combinations that we were trying there, and it results in these really large trials. So we definitely wanted to get in there with more treatments around particularly nitrogen management, but that wasn't always something that was possible. Generally speaking, and I have seen indications of this elsewhere, people talk about potential benefits of growing legumes with a non-legume in terms of the nitrogen nutrition of the non-legume. Now, I suppose there's a few different angles there. One is that if we're growing a non-legume in a situation with a lower plant density than we normally would, depending on how well that non-legume can compensate, its nitrogen nutrition requirement might actually be reduced. So in that case, we may see the productivity of that in terms of its nitrogen economics, if you like, improving. People do ask about the potential for transfer of nitrogen between a legume and a non-legume during the actual growing season, and I think that's an area that we certainly haven't done any work on. But looking at the research that's been done elsewhere, that's a real point of contention. You know, how much can be transferred within the growing season, and how available is it? Keeping in mind that, you know, when we grow that legume and it's fixing nitrogen, it's not necessarily immediately available. So that nitrogen that's fixed actually needs to then be mineralised back into a form that the non-legume can access. So there's probably a lot of question marks around that.
Thanks, Ash. Now, we will keep working through all these questions because there are a few, but understand that if people have to drop off, they can. An interesting one in terms of future plans and changing scope. Would you be looking to native grains in the Wimmera Mallee sites to sequester carbon and improve soils?
Native grains? Possibly. I can't say that I'm really across the potential of native grains to in terms of a carbon sequestration situation. But I think nonetheless, in that instance, I would be going back to first principles kind of approach. Much like I said before, I think it would come back to, what's the sort of initial productivity of that system in terms of the amount of carbon that it is putting in. What are any potential management practices that may be leading to loss of that carbon, and are we matching those carbon inputs with a suitable amount of nutrient input to enable the stabilisation and sequestration of that carbon? So yeah.
Thank you. Second last one. Did you find any weed management advantages, for example, crop competition suppressing weeds?
Good question. Couldn't say. Yeah, from what we've seen at Horsham and through our sites in the Southern Mallee and the Wimmera more broadly, yeah, couldn't say that we had too many major issues like that. But generally speaking, we do try to keep them as clean as possible. We try to throw whatever we can at the sites to make sure that they're not confounded by the effects of weeds. So, that I think if you were to do future work in this area, if we were to really keep pursuing this idea of intercropping as a system, I think there's a lot of things like that you would need to start looking into. The reality of this project is that we've tried a lot of different combinations of species across a wide range of environments to see how they've worked. Now, we haven't really delved into how we optimise the management of these different systems. It probably goes back to your earlier question too about nutrition. You know, there's a lot of further work that we could do to actually look at, right, if we work on the assumption that these intercropping systems are working well, how do we really optimise them to fit best and maximise their productivity?
Great. And a last question, Ash, and that relates to marketing. Could there be opportunities for sowing mixes that would then be fed to livestock? So, for example, mixes that were harvested together and then fed to sheep.
Yeah, that's one that I often think about. You know, whether it's harvesting a mixture as a feed mixture, or alternatively, I do wonder about the potential for a grain product that is a hybrid of two different species. I know, for example, there is work done around addition of products like lentils to wheat flour in order to bolster protein and things like that. So I think, there's a range of different potential ways we could go about it in terms of the end use of the product that might start to address some of those practicalities and the cost issues associated with trying to clean these grains and separate them out. Obviously, the easiest option would be if we can sell it as a product where the two are one commodity, that would be preferable.
Wonderful. So thank you very much for your time today, Ash, and thank you to our audience for joining in. The details of our next webinar in the series are on your screen, and I've put a link to the webinar registration in the chat. This presentation will explore the role of Longfellow brown manure and cover cropping in the context of modern Wimmera farming systems with well-respected local agronomist John Stutchbury. Once this webinar finishes, you'll be directed to a survey link. It would be very much appreciated if you could please fill it out for us. The survey won't take any more than 2 minutes to complete, and your input is really important for us in planning and evaluating this and other activities. Thanks again for participating in today's intercropping webinar, supported by Wimmera Catchment Management Authority through funding from the Australian Government's National Landcare program. I hope you all have a lovely day.